Good morning. Today I am going to demonstrate a MOSFET experiment. This is the circuit diagram of the MOSFET experiment. For this experiment, we require the following components. MOSFET. This is MOSFET IRF 740. In this, the first terminal is source and then drain. This is gate. Source, drain, gate. And resistor 1 kilo ohms, breadboard, connecting wires, voltmeters 2 numbers, and then ammeter 1 number. In this voltmeter, this is the positive terminal and this is negative terminal. In this milliammeter, this is the positive and this is negative terminal. In this voltmeter also, this is positive and this is negative terminal. The equipment is only the power supply. Connect the circuit. First, this is the source or drain gate. Source is connected to ground. Source is connected to ground terminal. So connect the source terminal to ground. Source is connected to ground. Then connect the drain here and then this side gate. So this is source, drain and this is gate. Now look at this figure. So this power supply positive is connected to the gate. Supply positive is connected to the gate terminal. Negative of the power supply is connected to the ground terminal. Connect negative of the power supply to the ground terminal. So positive is connected to the gate, supply negative is connected to the ground terminal. Then this voltmeter. VGS means voltage across gate and source. This voltmeter is connected in between gate and source. That's why it is called as a VGS. So VGS positive is connected to the gate and VGS negative is connected to the ground. Connect VGS positive. So VGS positive is connected to the gate. And then VGS negative to ground. Connect VGS negative to ground. VGS negative to ground. VGS positive is connected to the gate and VGS negative is connected to the ground terminal. Negative to ground. So this part is over. Next take the another power supply. So this power supply negative is again connected to the ground. Supply positive is connected to the one end of the 1K resistor. So connect this power supply negative to the ground. Second channel power supply negative is connected to the ground terminal. And then connect the resistor. So power supply positive is connected to the one end of the resistor. So connect supply positive to first end of the resistor. Then Other end of the resistor is connected to the ammeter positive. So this is the positive terminal. Ammeter positive is connected to the other end of the resistor. Negative of the ammeter is connected to the drain terminal. Ammeter negative to drain. Connect ammeter negative to drain. This is the drain terminal. Ammeter negative to drain. Then connect the voltmeter. VDS means voltage across drain and source. So connect the VDS positive to drain and VDS negative to ground. So this is the voltmeter. Connect in this. Positive terminal is connected to the drain. So voltmeter positive is connected to the drain and then voltmeter negative to ground. Negative of the voltmeter is connected to the ground terminal. Voltmeter positive is connected to the drain and voltmeter negative to ground. Then multimeter, it should be in volts, DC volts. This also switch on the multimeter and adjust with the volts, DC volts. This is also DC volts and this is also DC volts. Then before switching on the power supply, keep the voltage knob in minimum position and current knob in maximum position. Switch on the power supply. Now adjust the VDS. VDS means voltage across this drain and source. With respect to this power supply, adjust the VDS at 5 volts constant. So with respect to this power supply, adjust the VDS 5 volts, then keep constant 5 volts. 5 volts. Then vary the VGS in steps of 1 to 3 afterwards 3.1 to 4 volts with respect to this power supply. By using this power supply, vary the VDS. First 1 volt. So adjust VGS with the help of this power supply here 1 volt and then note down the ID. At 1 volt it is 0. Next vary the VGS. VGS 2 volts. Adjust 2 volts. And 2 volts and note down the current. At 2 volts also we are getting 0. Then adjust 3 volts. So at 3 volts also we are getting 0 only. Next 3.1 volts. So at 3.1 volts, 3.1 we are getting 0 only. Next is 3.2 volts. So at 3.2 volts we are getting again 0 only. Next is 3.3 volts. So at 3.3 volts, (3.3) also we are getting 0.5, and then adjust 3.4 volts. So at 3.4 volts we are getting 1 milliamps. Then adjust 3.5 volts. So at 3.5 also we are getting 1 milliamps only. And then vary the voltage at 3.6 volts. At 3.6 volts we are getting 2 milliamps. Then 3.7. So at 3.7 we are getting 4 milliamps. Here 4 milliamps. Next is 3.8. So at 3 point also 4 milliamps. Then adjust the VGS 3.9 volts and then note on the ID. Now also 4 milliamps. Then adjust 4. At 4 also we are getting 4 milliamps. Next, decrease the VGS voltage. Then increase the VDS and then keep VDS 10 volts constant. Then vary the VGS in steps of 1 volt, 1, 2, 3. So at 1 volt we are getting 0. Next is 2 volts. So at 2 volts also we are getting 0 only. Next is 3 volts. So at 3 volts also 0. Next is 3.1 volts. At 3.1 also we are getting 0. Next adjust 3.2. At 3 point also we are getting 0 only. Next is 3.3 volts. (3.3) At 3.3 also we are getting 0 only. Next is 3.4 volts. So at 3.4 volts we are getting 0.5 milliamps. Then increase 3.5. At 3.5 we are getting 1 milliamps. Next is 3.6. So at 3.6 also same 1 milliamps. Next is 3.7. At 3.7 also, at 3.7 we are getting 2 milliamps. And then 3.8. At 3.8 we are getting 5, 6, 7 milliamps. Next is 3.9. (3.9). So at 3.9 volts we are getting same 7 only. Then 4 volts. At 4 also same 7 milliamps. So this is the equation. Next is for enhancement mode, keep both the voltages in 0 position and then see the reading. At 3 volts we are getting 4 milliamps. So keep this VGS as a 3.7 volts. Keep VGS as a 3.7 volts constant. And then vary the VDS in steps of 0.1 to 1 volts. For second case, we are getting at 3.8 volts constant. So keep VGS as a 3.8 volts and then vary the VDS in steps of 0.1 to 1 volts. Now keep VGS 3.7 volts constant. 3.7 volts constant. With respect to this power supply, you have to adjust here. So 3.7 volts. 3.7 volts. Then vary the VDS in steps of 0.1 volts. So increase the VDS by 0.1. So at 0.1 we are getting 0 only. Next is 0.2. So at 0.2 also 0. 0.5. At 0.2 we are getting 0.5. Next is 0.2. At 0.2 we are getting 1 milliamps. Next is 0.4. 0.4 also 1 milliamps. Next 0.5. So 0.5 also 1 milliamps. Next is 0.6. 0.6. 0.6 also 1 milliamps. So vary up to 1 volts. It remains constant, 1 milliamps only. Up to 1 milliamps we are getting constant. This is the reading. So at 0.1 volts we are getting IDS 0, 0.2, 0.5, 0.3 volts 1 milliamps. After 0.3 it remains constant. Up to 1 volts we are getting 1 milliamps. For second case, adjust the VGS as 3.8 volts. So keep constant. Then here adjust the VDS as 0.1 volt. So at 0.1 we are getting 0. Next is 0.2 volts. So at 0.2 we are getting 1 milliamps. Then 0.3. So at 0.3 also 1 milliamps. Next is 0.4. So at 0.4, 2 milliamps. Next is 0.5. 0.5 also 2 milliamps. So vary 0.6, 0.7, so it remains constant. 0.8, 0.9 up to 1, it is 2 milliamps. This is the MOSFET experiment. So for second case at 0.1 volts 0, 0.2 volts 1 milliamps, 0.3 also 1 milliamps, 0.4 2 milliamps, 0.5 2 milliamps, 0.6 2 milliamps, 0.7 2 milliamps, 0.8 2 milliamps, 0.9 2 milliamps, 1 volts 2 milliamps. This is the